All right, so before we talk about how to solve these types of equations, I want to go over the vocab. So right here at the very top is a little picture. It says index and radicand. This whole unit is about radicals. I know you've heard the word radical. It's not ratio, so it's not a fraction. But this symbol right here with the little check mark on it and everything, that is called a radical. What else do you guys frequently call this symbol? A square root.
Yeah.
Well, it's called a radical, just the symbol itself. You guys say square root because the index, the number that's inside the little check mark, is actually a 2. You just can't see it. We know of it as being a square root. So then here's another radical symbol, but I'm going to change the index to a 3. Is it still called a square root? No, it's a different type of radical, and this radical is a cube root. And then if I change the index again, here's another radical, but with a 4 as the index. This is a 4th root, and then so on. If I keep changing the index, it changes the type of radical. So when I say the word radical, I mean all of these. Radical is like an umbrella term. But when you're being specific on what type of radical, it depends on the index of it. Does that make sense? Okay, so what do we call the values that are underneath the radical symbol? So if I put an x in here, a 3 in here, a y plus 2 in here, what do you call those underneath it? Say it. Radicand, because it goes underneath the radical. Okay, so let's put a little example up here. I'm going to put this. How would you guys read this to me? Like in words, what would you say? Not 3, because then it would say a 3. It has the 3 as an index, so that means what? Cubed root of x. There you go. That's how you read it. Cubed root of x. Don't say 3 root, because that sounds weird. It's a cubed root. It's kind of like an exponent, but it's an index of an exponent. And then to be specific, what is the index when you see it? 3. And the radicand is x. Okay, now so this one, same thing, but with the what? How would you read this? Square root of x. I don't know why I put a colon there. I meant to put the little quotation marks. My bad. Okay, so what's the index on this one? It's a 2, because remember the square roots have an invisible index of a 2 here. And then the radicand is again a x. So in case you forget, when you hear me say the word index radicand, at least you know what I'm talking about. All right, moving on. So we want to talk about how to solve equations that deal with radical symbols. It's very similar to how you guys think of inverse operations. So for instance, if I give you a plus 3, what's the inverse that gets rid of a plus 3? A minus 3. And then they go away, right? What's the inverse of me having 3 times x? What? Say it again. Divide it by 3, and then they go away. Those are inverses. So the same thing is going to happen with these. We want to figure out what is the inverse of a square root. The inverse means we're going to square both sides. What you do is you raise it to the power of your index. What is the index of a square root? A 2. So if I square this, it cancels off the radical symbol. That's an inverse operation. But if I square the left side, finish the sentence, you do it to the other side. So I also square the 3. Okay, then what am I going to be left with if the radical symbol goes away? X equals 9. And if you plug that back in, is it true? Is the square root of 9 equal to 3? Yes, because 3 times itself is 9, right? So the square root of 9 is going to be 3. Okay, same thing over here. Let's solve this one. Well, I have a square root again, so I'm going to put parentheses around it, square it. That gets rid of the what? Hello? Yeah, I know, she screamed. What does this get rid of?
It cancels out the index.
Cancel out the what?
That cancels out the index, like the square root.
The square root. Or you could say radical. It cancels that out, and then you're left with x equals, now I want you guys all to put this in your calculator. I know it seems like you already know the answer. I'm not going to tell you how to do it. I just want you to put this in your calculator and tell me what you get. 9.
hate to bother you, but is there a softball game for the girls?
Yes.
Yes, thank you.
No problem.
Okay.
What'd y'all get? Everybody got 9? Everybody got 9. Don't lie if you didn't get 9.
Every single person in this room got it.
I doubt it. I'm pretty sure somebody got negative 9
I
in
got
here.
9.
Well, then that's good. That means all of you guys use parentheses. So if you didn't use parentheses and you put it in your calculator like this, it's going to tell you negative 9. Because it thinks that you're squaring whatever's directly attached to it, which is just 3. So if you square 3, you get 9, but then you're multiplying it by a negative. That's what the calculator thinks. So if you don't use parentheses like this, it's going to read it wrong because now the square is attached to the parentheses, so that way it knows you're squaring the negative as well. Just make sure you're using parentheses when you do that squared function. All right. So on both of these we got 9, but yet they started with different numbers. Anybody know why that is? Why could the square root of 9 be 3 and negative 3? Go for it.
Isn't it because you can't square a negative number? Like if you square it, it's going to be positive.
So what you're saying here is like if you square root something, it's not going to give you a negative, right? That's very true. But the opposite of that, can you square a negative? Every time you square something, what are you always going to get? A positive, which is why we can't square root a negative because we're never going to have a negative. But I'll go into that a little bit later. For right now, I just want y'all to focus on which one of these is actually true. Which of these can you take the square root of? The example A. Why? Because if you plug in 9, square root of 9 is 3. If you plug in 9 here, the square root of 9 is 3, not negative 3. This is what we call an extraneous solution. What that means is we did the math correct. We got the correct answer. But when we plug it in, it makes a false statement. It's not a real solution. It's extraneous. What did I just say? It's a what? Okay, so we've got into the concept before, plugging it in. Is it true or false? That's what that means. If it's false, it's going to be extraneous. All right, so then what about if I have a cubed root? What if we had an index of a 3? Well, that looks like this, right? A radical with a 3 inside the check mark. If I had an index of 3, would I have squared? No. And so to undo this radical, I would put it in parentheses and raise it to the power of 3, whatever that index is. So we would have cubed instead of squared. All right, we ready to do some harder ones now? That was just to get you guys to understand the inverses. This is weird. Y'all are all quiet. All right, so example C and D I'm going to do with you, and then I'll have you do E on your own before we flip it. All right, so example C, draw a line down your equal sign, because remember what we do to one side, we do to the other side of the equal sign. Right now, here's my x value. The x value is underneath the radical. Consider it like being trapped inside of a room. Everything is trapped underneath this radical. We can't get rid of it until we get rid of the radical itself, but there is something else still surrounding it over here. So step 1 says isolate the radical, meaning get rid of all the values that are outside. So what number is not underneath the radical? Okay, well, how do I get rid of minus 4? There you go. And then we rewrite. 0 plus 4 is 4. Are there any other numbers outside the radical? That's fine. Just bring it back. Any other numbers outside the radical? Well, yeah, but is there anything else outside that right now? Like not the index. That index is part of the radical. So what's outside the radical? Is there anything else outside? Thank you. As well. Okay, the 4 is on this side, so cover it up. Do you have any numbers on the outsides of the radical? Or is everything underneath it? Do we not understand the question? Okay, so here's the radical symbol, right? Is there anything on the left or to the right of the symbol right here? Is there anything to the left of it? Is there anything to the right of it? Is there anything surrounding it? All right, there's your answer. So everything on the left side is directly underneath it. So now we move on to step 2, which says apply the power rule. How do I get rid of that radical symbol? Well, this is a cubed root, so what power am I going to raise it to? 3. Raise it to the third power, which means I also have to raise 4 to the third power. What does that cancel? Why did I do that? It cancels out the radical, the cubed root. So now we drop down the radicand. We drop down what's underneath it, which is 4x minus 8. And we get what 4 cubed is? Put it in your calculator if you don't know. We'll use the little caret thing. It's not 16. That's 4 squared. 4 cubed. So 16 times another 4. 64. And now we're back to a normal equation. You cover up the 64. Furthest thing from x is the 8. Add 8. Add 8. Gives you what? And last step here, cover up 72, and 4 is attached, meaning multiplication. So what do? Divide by 4. And we get x equals 18. Now before we assume that this is correct, remember above it looks like it's mathematically correct, but it could be extraneous. How would I verify that this is real or extraneous? Just plug it in for x. So I'm going to get my calculator. There's a special button for cubed root. You cannot go and put an exponent there on your own. So everybody hit math right here. Hit math, and then option 4 says cubed root. You hit 4, there's your cube root symbol. And now we're going to just plug in x for where x goes. So we get 4, parentheses, what's x? Close it, minus 8. Now why is this blinking right here? What is it telling you? Yeah, if you want to get out of the radical, do we? Is the 4 outside or inside? Outside. So then how do I get out? I'm going to hit the right arrow. Now you're outside the radical, and we put minus 4. Push enter. So is it true? Yes. So that means that this is a real solution, not extraneous. I'm just going to put a check mark there saying that we checked it. Yeah, and tell Justin to hurry. All right, example D, and then you're going to do E on your own. Okay, D is just a little bit longer. If I cover up the right side, look around the radical. What type of radical is this one? It's a square root. Because is that 3 in the index? No. So you can't call this a cubed root, even though there's a 3 there. What is the 3 doing if it's directly in front with no sign in between? It's multiplying. Remember in math we say when things are attached, they're multiplying. What is the 9 doing? It's being subtracted. So this may help some of you guys. When I say isolate the radical, think about it as me saying 3 is attached to something, minus 9 equals negative 3. If I ask you to solve for whatever is in here, what would you have gotten rid of first? You can pretend there's anything in here. I just call that entire radical something. What would you have gotten rid of first? Would you have gotten rid of the 3 or the 9? Okay, what if I put an X here? You still would have got rid of the 3?
The 9.
I cover it up. What's furthest from X?
The 9.
The 9, because it's not attached to it. So how do I get rid of the minus 9? You would add 9, right? And then we would get 3x equals 6. And then I cover the 6 up. If the 3 is attached, that means that it's multiplying. So how would I get rid of that? Divide by 3. So you understand the steps. If I put a letter there, you're doing the exact same steps with this radical. You are trying to isolate the radical by getting rid of those outside numbers. So the 9 is furthest away because it's not attached to it. How do I get rid of the minus 9?
Add 9.
Then copy the rest down. 3 square root 2x minus 1 equals 6. Cover up the 6. Now the 3 is attached to the radical, meaning multiplying, so we divide by 3. And we get square root 2x minus 1 equals. Question on how to isolate the radical. Michael, you need one of these? Do you need one of these? All right, so now if I cover up the 2, can I start by adding 1 to the other side? No, because like I said earlier, they're all trapped underneath the radical. What do I do to get rid of this radical? Square it, because the index is a 2. Square the 2 as well, cancels off the square root. Drop it down. 2x minus 1 equals 4. Now we're back to normal. Okay, so we cover up the 4. Furthest thing from x is the 1. Add 1 to both sides. Cover up the 5. How to get rid of the 2 that's attached? Which means we get x equals or we could have left it as 5 over 2. Either or. Okay, and then the last thing is plug it in to see if it's real or extraneous. So you get 3 square root 2 times 2.5 minus 1, inside or outside?
Outside.
So hit the right arrow, and then minus 9. Do we get negative 3? Yep, then it's real. Okay, so I want you guys to do example E now. It's doing the exact same thing as what I just did. And if you can do that, then we'll flip it over and we'll make it just a tad bit harder. I'll come over here and I'll catch you up. So we're solving equations for a variable. The only thing is that we have things with square roots and cube roots now. So I taught them like if you have a plus 3, how do you get rid of the plus 3? And you subtract it, they cancel. If I have 3 times x, I divide by 3. They cancel, those are inverses. Right? Well, when you have square roots, that's something. You're going to raise it to the power of the index. So that means it's whatever number is here. Well, you said square root. So this is a squared index. If you square it, it changes it off. If I had a cubed root with 3 in the index, I'm going to raise all of this to the power of 3, and it cancels off the cubed root. So inverse operations. Okay, so over here, if I were to solve for x, I'm going to take all of this. Well, this is a square root, so I'm going to square it. Which means do the same thing to this side. 3 squared. That cancels off the square root. What's left underneath? And then 3 squared is 12. Okay, same thing with this one. If you square it, x, what's negative 3 squared? Negative 3 times itself. Okay, however, even though we had 9 on both of these, anytime you square root a number, it's always going to give you a positive.
It's just like
So on this one, even though I did it automatically correctly, if I put in a 9 here, square root of 9 and automatically doesn't tell you this. Square roots will never tell you your negative number. So we call this, even though we did the math correctly, we're going to call it something that's still correct, but I'll explain a little bit more. Extraneous means like on a graph and stuff, but for right now, just know that one makes the equation true and one will make the equation false. So just plugging it back in and seeing if true or false tells you whether or not it's real or extraneous. This would be extraneous. Not that it's wrong, because we did the correct math. It's just we would call it extraneous because it's not a true statement. Square root of 9 is calculated, it will tell you positive or negative.
So if I do this,
You have to just tell me extraneous. Like you'll tell me real or extraneous. Like you didn't do the math wrong, is what I'm saying. Like it's not a real solution, but you didn't do the math wrong. Okay, so on these, like I said earlier, do the square root, do the square root, do the cube root, do the cube root. So that would be the inverse side of cube root. Okay, so I did this one with them to start with. First step, isolate the radical. So if there's anything surrounding the radical, like to the left of it or to the right of it, you want to get rid of those outside values. Right? So on this one, we have a cube root, but what is outside of that cube root? So get rid of that outside value first before you take care of the radical. So get rid of 4 by adding. Right? Subtracting. Then we get cube root. And now, since you don't have the outside values, you're going to apply that power relation. So what's the inverse of the cube root?
cubic. So I put it in parentheses, cubic, and then
I don't know if that's her name, it's pronounced.
break down. So we get 4x minus 8 equals 64. So that's 4 cubes.
Never talking about Miss Virgie trying to get into.
Yep, and now it's basic problem that you're using for cover 64.
And I grabbed her by her little pocket and Miss Virgie, give me the pocket before you get hit. She's like, okay, okay. And the other teacher pulled her back out. She's like, help me separate them. And I was like, I'm trying to Miss Virgie, you're to help. But she needs to get bigger back.
Yep. So then from there you can just plug it in like how I showed you here. If you plug it in and
She
it's
was
true,
crying
if you
really fast. She was like,
plug it in and it's false, then it's an extra. Yeah, for the X. So your calculator, there's a button for the cube root symbol, and that's right here. You go to hit math, and then option 4 tells the cube root symbol. Pop the cube root symbol, and then put 4 parentheses, whatever my X is, 16. Minus 8. And then see how that 4 is outside the radical, so then here it's blinking an arrow to tell you to hit the right arrow to go outside of it. And then you put minus 4. Sorry, if it's 0 equals 0, it's true. It's a real solution. Okay, try out this one. Do the same thing. It's just this is square roots instead of cube roots, but it's literally the same.
Alright. And ignore me while I talk. Okay, so let's see what y'all should have did. What number did you guys get? 35, and was it real or extraneous? Why? Thank you. Alright, so you should have subtracted 2. I'm just going to do it really fast for those of you that did not get that. And then from here, you would have raised everything to the power of 2. And then you would have subtracted the 1. And then when you plug it back in your calculator, we get 8 and not negative 4. Therefore, it is a false statement. We call this an extraneous solution. All right, can we make it a little bit harder? All right, I'm going to do example A. You're going to do example B. Ignore the application at the top. We'll do that later. It's doing the same thing we're already doing. Just has a fraction in the front. What?
We don't want to do this.
Don't want to do what?
It was hard.
Okay, it's actually not that hard. So, what'd you get?
You gotta square this side though. When you squared that, you're supposed to square this as well. So that gave you 36 here. And 36 minus 1. No, this is 36, so that would be a 36, and then minus 1.
Negative 36?
Positive 36, and then minus 1. 36 minus 1 is 35. 36 minus 1. Minus 1. I was like, you wrote negative 1 there as well. Alright, so on this one, we have x's on both sides, but I can't do anything with these x's. Madeline.
I'm ready.
Okay, I can't do anything with these x's because they're both trapped inside the radicals. Focus on one of them. If I cover this up, how do I get rid of this radical? You're going to square it. So put parentheses around it, square it, which means put parentheses around the other one and square it. What happens to both?
They cancel out.
All right. So then we're left with what's underneath. X minus 4 equals 2x minus 13. So we still have an issue because we have x's on both sides. If you have variables on two different sides, focus on combining those variables together. It doesn't matter which way you go, but I like to keep it positive. So which one would I move?
Okay,
X minus 4.
Yeah, I'd move the left side because you want to keep positive to make it easier. So if I want to get rid of this x, subtract x here. Yeah. We're getting your variables together. You're combining the like terms, your variables. So x minus x will cancel out on the left side, but it moved it to the right side to be able to combine. And what's 2x's minus 1x? Just an x. Everything else, drop it down. Okay, any questions there? Okay, then we're back to normal. I cover up the opposite side of my variable. What do I got to get rid of? 13. Add 13, add 13, and we get x equals 9. Now, if we're plugging it into this one, we can't just plug it into the left-sided no, because they both deal with variables. So I got to plug it into both sides to see if it's true. Doesn't take that long to plug in, though, especially when you have a calculator. So I get 9 minus 4. That's what I get on the left side. Now I'm going to do the same thing. I'm going to plug it into the right side on a separate line. Square root of 2 times 9 minus 13. Did I get the same value on both sides? Then it's true. It's a real solution. Okay, go ahead and try out example B. It's doing the same thing, but with cube roots. Literally the same thing, but with cube roots. And then I just got 2 more that I want to go over. Bless you.
Maddie, I didn't even see it. It's the same thing like over here, but it's with 3. Something different. They were in the exact same thing. I'll see it.
You're not doing it. Try this one. I'm just curious if you can get it without Michelle. Let's do it. Yep. And then plug it in. You don't have to touch it. Just be careful because the 2 is tricky on this one. It sometimes doesn't show up. Have you been home? No?
We said math, right?
Math and then number 4.
Okay, I divide them.
Do you divide them?
You got it?
Do the same thing to the right side. I got right. The same.
Oh,
Here you go. See if that works. Yeah. Yeah. All right. We need more time? No? What did we get? 9 again. And was it real or extraneous? Real.
I got 3.03.
Okay, so you should have cubed both sides. I'm going to do it really quickly. You would have combined your x's. And then you would have added 2. And then you would have got x equaled 9. And then when you plugged it back in, it was a true statement. So, see, it's not that hard. You're like, no, don't get harder. All right, tad bit harder. And then the last one we do will be the hardest it will get, okay? Example C. Building blocks. All right, draw a line down the equal sign. Cover up the radical, and that says just x. Can't do anything with x, because then those x's are underneath. They're trapped. So I can't do anything with these x's until I square them, because if I square this, now everything comes outside the radical. But I also need to square the x. So the square root cancels, drop everything down. What is x squared? Trick question. X squared. Can't change that, right? Can't do anything. It's just x squared. That's why I said trick question. Okay. Now, what does your brain think automatically when you see this before we keep going? Your brain automatically goes to factoring, which is great. I love that I instilled that in you. However, Do we have our like terms together yet? So don't go straight to factoring until you have nothing else to do and you can't solve it. Because what's going to happen? Well, we have our x squareds that we can combine. So it doesn't matter which way I go. I'm going to move this one over here. Subtract this x squared and then subtract it here. What happens? Cancels out. So I'm really left with 0 on the left side. And what's on the right side? Well, we got negative 5x and 15. So is this something that I have to factor in order to solve? No, you don't have any exponents in here that says expand this out. So just solve for x the usual way. Cover up the opposite side. Furthest thing away is the 15. Keep going. Minus 15. And last step, cover up the negative 15. And what is the negative 5 doing? It's multiplying because it's attached. So divide it by negative 5. And we get x equals 3. Alright, and so to save some time, this one is a real solution. I understand that you guys know how to plug things in. So that's a real solution. It will work out. Alright, you ready? This one's probably the longest one. And it's because it will involve factoring, actually. But I'll see if you guys can remember. So before we do this, when we factor something, like let me give you an example just to recap something really quick. If I were to factor this, all right, and you guys know how to factor, so I'm going to do it really quick, you would get x plus 3 and x plus 2. What do you want these to equal so that way you can solve it? 0. Why 0? I taught you guys that 0 principal rule. It's not fractions. What do factors do? They're being what? So why do we want 0? Because we can say anything times 0 will be 0. So if this number was not 0, do I have a rule for anything times something is 5? Anything times something is 6? No, but if this number is 0, then I can solve it. What x makes this 0? What x makes this 0? You solved it. Okay, so keep that skill in your brain. Whenever we're factoring something, we want it to be 0 so we can solve it. Otherwise, it won't be solvable. All right, let's get started. Draw a line down the equal sign. Anything surrounding the radical. All right, so how do I get rid of this radical? Square it, which means I also square all of this. What does it mean to square something again? Multiply it by itself. What is it that I am squaring? Read to me what I'm squaring. X plus 1, which means I take x plus 1 and I multiply it by x plus 1. That's squaring. You multiply something by itself. Question there. Okay, drop down the other side because that canceled. Did you get it? Did you get it? All right, so from here, can I combine x's? No, because we got parentheses. Then distribute. X times itself. X times 1.
That's 2.
And 1 times x.
Oh, shit. Oh, what the hell?
And 1 times 1 is not 2. It's 1. Okay, now we have like terms that we can combine. What should we combine? Okay, on the right side, we have these 1x's to combine. 1x plus 1x is 2x's. And do we have any other like terms?
No.
Not on each side. So then let's look. Can I move anything on the left side with the right side? We have the x's still to combine. So if I add x and I add x, we get 5 equals x squared plus 3x plus 1. All right, so now look at what we have. We have all of our variables combined. Did the x squareds go away?
What?
No. So is this something where I could solve it usually like this, where I just get it by itself? It won't work that way. You can think of this as having two separate variables. If I were to give you an equation like this, would you ever be able to get x equals a number? Looking at that. Moving everything over, will you ever get x equals just a number? No, because you have a whole completely different term. You have a y in there. Same thing with this. You have two completely different terms. This is an x squared and this is an x. You're never going to be able to get x by itself. So I taught you guys to factor, to break up that exponent. Can I factor and solve if it equals 5? What did we say earlier? Has to be 0. So then make it 0. How do I make 5 0? Minus 5. And now we can factor. Okay, so I'm going to go up here. We can use what rule to factor this since your a is 1? I just said it. Never mind. A equals 1 rule. All right, a times c is? B value is? 3. What factors is negative 4? Gave you 3. 1 and 4. Which one's negative?
Oh my god.
The 1 is negative. All right, so we get 0 equals x minus 1 and x plus 4. We're practically done. What makes this 0? 1. So x equals 1 is one solution. And then what makes this 0? Okay, so those could be both real solutions. One could be extraneous. You never know until you plug them in. That's like as long as I will make it for y'all right there. Just it requires factoring. That's why it was longer. But you should know how to solve by factoring.
It's hard.
No. I don't want to hear this was hard. Y'all's last stuff was hard.
Wait, so when you plug those
That made me.
Say it again.
when you plug those answers in to figure out which one it is.
Yeah, you do one at a time though. So start with like how we did over here with the 3. We plug 3 into that and to that to see if they're equal. Do one at a time though. All right, so go ahead and plug in 1, guys. Check the 1. Plug in the 1 over here and the 1 over here. See if they're equal. So square root 5 minus 1. We get 2. And then on the right side, 1 plus 1. 2. So does 1 work? Yes. Okay, clear it. Now let's try negative 4. Be careful when you plug in negative 4 because you absolutely need parentheses when you substitute. We have 5 minus parenthesis. What is x? You don't know how many people did not put it this way and they just left it as 5 minus 4. It says 5 minus x, so you have to put the minus in between and parentheses where your x is. That gives you 3. So now plug the negative 4 into the other side. Negative 4 plus 1 is negative 3. Is it true? So then we say negative 4 would be the extraneous solution. All right.